Okay, so we're adding and subtracting radical expressions. To add or subtract radicals, the inside of the radical must match. So, like, if you have 4 root 3 plus 7 root 3, do you see how the radicals match? They have the same root and the same base on the inside. That means you can do 4 plus 7 root 3. Okay? So when adding or subtracting, they have to have the same root and the same insides. Okay? Now, when multiplying, do they have to be the same? No. And remember, you can just multiply them as long as the root's the same. Same with division. So adding and subtracting, they have to be the same. Multiplying and dividing, they do not. Okay? So knowing that, let's get started. If you look at number 1, it says 3 fourth root 11 PQ minus 7 fourth root 11 PQ. Do the radicals already match? Yes. Okay, and can they simplify? No. 11's prime. P and Q, there's just one of them, so you can't take out because you would need 4 to take it out. So knowing that, we're literally just doing 3 minus 7 fourth root 11 PQ. What's 3 minus 7? Okay. Now on number 2, do they already match? No. Okay, but they can simplify. 64 is a perfect cube, and we're looking for the cube root. So remember, I like to see us make something cubed, something cubed, something cubed. So I know I have cube root. So I need something cubed, something cubed, something cubed. Okay, well, what cubed gives me 64? 4 cubed. Now, m to the 4th power. Well, I only need 3 of them. How many times does 3 go into 4? So I can only put 1 m here, and how many do I have left? If I put 3 m's here, how many do I have left? 1. So that other one's going to come at the end. Now, if I need something cubed, but I have 5 n's, I can put 3 of them here, but I still have 2 left over that didn't fit in there. It means we're still going to have a radical even after we simplify, because these cannot simplify because they're not cubed. So I'm going to go ahead and rewrite cube root of m n squared. Okay, and because the cube root cancels this cube, and this cube, I can take out a 4mn. So all I've done so far is simplify the cube root. Okay, I'm going to bring down the minus sign so I don't forget about it. And now I'm going to simplify this one. Now, is it okay to have a negative on the inside of a cube root? Is it? Yes. It just can't be inside something that's even. Okay? So what cube gives me negative 27? Negative 3. How many times does 3 go into 10? 3 times, and that gives you what? 9. So how many do I still have left? 1. So that 1's going to come on the end. How many times does 3 go into 14? Almost. 4. And that gives me 12. So how many do I still have left? 2. Okay, so again, this cannot be simplified because they don't have something cubed. So I'm going to go ahead and then the cube root cancels this cube, and this cube. So I have negative 3 m cubed n to the 4th power. Two negatives makes a, And I'm going to combine what's in front now that the roots match. Now, can I simplify this? Can I simplify this?
Yeah.
No, because this is m cubed and this is just m. This is just n and this is n to the fourth power. So we cannot simplify this any further. Now, if you left it like this, I won't count off because really that's as simple as you can get it. I just rewrote it differently. Okay? Okay, so that's something like that. So now let's look at number 3, 4, and 5. What are we going to do here?
We're going to simplify it.
How?
You need to match it. So 50.
Not yet.
Oh.
What do parentheses represent? Addition, subtraction, multiplication, or division. We have to double distribute because we have 2 terms here and 2 terms there.
So we're just going to 50 times 2.
So now with multiplying, can we multiply the numbers as long as the root's the same? Yeah, so what's 50 times 2? 50 times 6, and be careful, this is negative. A positive times a negative is negative. What's 50 times 6? Well, the negative's on the outside. Negative square root of 300. Then we have 27 times 2. And then we have root 27 times negative root 6. Which is going to be a negative 182. 162. Everybody okay with what I've done so far? Maybe. Okay, so now we can simplify our radicals. Which one of those is a perfect square? 100. So what is the square root of 100?
10.
10.
Can you get louder, bro? Oh my god.
Who is that?
That's what JD Clinton.
Oh. Is it Ethan? Oh. Okay, so then this one. So there's 2 ways to kind of break these down. What goes into 300? A 3 and 100. Isn't 100 a perfect square? I'll bring down the minus. So technically, what's the square root of 100? 10. And then I'm left with that 3 still on the inside. Because you're right, I can rewrite this as 10 squared times 3, and the square root cancels the squared. But the 3 didn't have a squared, so it stays. Okay, what about 54? Now, I can't think of this one like that, so I'm going to do the factor tree. Square root, so I'm looking for pairs of 2. So 2 goes into 54 27 times. 3 goes into 27 9 times. 3 goes into 9 3 times. Because it's a square root, I'm looking for pairs. That's a pair. Are those a pair? No. So I bring that 3 out. And what's 3 times 2? So that goes back in. Not adding. Okay, now 162. I'm going to bring down my minus so I don't forget. 2 goes into 162 81 times. Isn't 81 a perfect square? Yeah, because 9 times 9. So I can stop and just write it like this. Now, does any of that simplify together? Because now we're adding or subtracting. Can I add or subtract any of that? No, because none of the roots are the same on the inside. So that's your answer. Huh? No. Oh, there's a whole nother packet. What does squared mean? Mm-hmm.
I'm multiplying the exponents.
Isn't it just multiplying it by itself?
Oh, yes.
So this can be rewritten we cannot, however, just put the squared in there because you're not going to get the same answer. And again, we double distribute. What's 4 times 4? Now, what's 4 times 3 square root of 6? Well, this is not a radical, so I'm going to multiply it by what's not inside the radical. What's 4 times 3? And it still has that radical 6, but it didn't change because there was no radical over here. Okay, and then 3 square root of 6 times 4 is again 12 square root of 6. 3 square root of 6 times 3 square root of 6. Well, 3 times 3 is, but what's 6 times 6?
36.
Because they both had a radical, I will also multiply both the radicals. So what's a perfect square here?
36.
Yeah, what is 6? I mean 36. 6. Okay, square root of 36 is 6, and I know that these two are like terms, correct?
Yeah.
So I can combine them. What's 12 plus 12? So I still have this 16 in front. And what's 9 times 6? 54. Now what can I combine? Yeah, what's 16 plus 54? 70. This is your answer. Now, proper is to write whole number before radical. So we have 70 in front of the 24 square root of 6. Okay, I'm going to actually do this last problem, and I'm going to do one of them from the practice with you because it's a little different. So let's look at number 5. So again, same concept. We have to double distribute. So here, they're both radicals. What's 2 times 8? Now, this is inside a radical, and this is not. But I can technically say that this is 1 square root of 2. Did I change anything? No. So what's 1 times negative 5? And then the root 2. Okay, so then I'm going to do 3 root 8, which is positive, and 3 times negative 5, which is negative 15. Are any of these perfect squares? Which one? Square root of 16. What is the square root of 16? Okay, I'm going to bring down my minus. This is prime inside the house, so that cannot simplify. Now, what about this 8? Can that simplify? It's not prime, so maybe. If you're unsure, build your factor tree. 2 goes into 8 4 times. Well, 4, yeah, no. 2 root 2. But wasn't there a 3 already there? So bring that 3 down. What you took out is going to multiply, and what's left over goes on the inside. So that, I will tell y'all, is the biggest mistake I've seen today, is people forgetting about the number that was already there. Okay? So be very careful with that, and then I'm going to bring down my minus 15. So what are my like terms? Well, first, what's 3 times 2? 6. So this is just 6 square root of 2. So what are my like terms? So what's 4 minus 15? And what else is like terms? So what's negative 5 plus 6? What's that?
So when you're a teacher, can you
Like how many days we get to spend on something?
It's like speed running, slow running, price because and then just have a bunch of free time at the end of the year.
Y'all wouldn't be successful.
But can you do it?
If I want it? No, I'm not supposed to. Okay, I'm going to do one of the practice ones. I want you to look at number 3 on the practice. Just because this one's a little different. We did do a cube root problem on the front, but we didn't do a cube root that wasn't perfect cubes. I mean, they had variables that weren't perfect cubes, but the numbers. So it's a little different. So 40 is not a perfect cube. Okay? 40 is not a perfect number at all. So what I want you to do is build your factor tree. 2 goes into 40 20 times. 2 goes into 20 10 times. 2 goes into 10 5 times. Are all of those numbers prime? Yes. But I want you to realize we were doing cube root. That means I need 3 numbers to match. So I have 2 3 times. Therefore, I can take the 2 out. And I have cube root 5 left. Do y'all see what I'm saying? Okay, because this is cube root, well, that just means third root. I need 3 numbers to match to take it out. With square root, that's root 2, so I can have 2 numbers that match to take it out, but this is different. So then 625, now I want you to realize I'm going to bring down that minus 5 because I don't want to forget about it. Okay, but let's look at 625. 5 goes into 625 125 times? Yes. Okay, I know 5 goes into 125 because it ends with a 5 25 times. And 25 is a perfect square of 5 and 5. So what's my group of 3? 5s. So 5, cube root, what was left over? 5. So I know that I'm going to have a cube root 5 answer. Yes? Because both of them have cube root 5. Well, what's negative 5 times 5? What's 2 minus 25? So this is the main thing I wanted to go over, is breaking down a cube root versus a square root. Okay?